Decided that I want to make a quick video on the differences between these different diffuse lighting models. So the first lighting model is Lambert. The second lighting model is half-lambert. The third lighting model is wrap diffuse. And the fourth one is, I'm probably butchering the name, Ornair. And on this sphere is half-lambert as well. So as you can see, the wrap diffuse and the half-lambert don't quite look the same. The half-lambert is more gray and sort of washed out. So the real difference kind of comes when I turn the light source over to the side. So as you can see, there's sort of a harsh fall off between the lit side and the unlit side. So this is the fall off, and as you can see, it's really bright here in the same plane that the light is facing head on. When it comes to half-lambert, what's going on is you're basically taking this fall off and you're extending it out. So if you remember remember my previous video where I was talking about the lit side and the unlit side. If on a sphere, generally the vertical poles, or if you have the light source at the horizontal pole, the vertical pole basically separates the lit side from the unlit side. So you have the fall off happening on the lit side, and then everything on the other side past the vertical pole is completely unlit, and would normally have the unlit color. The unlit color is usually it's supposed to be pure black, but my Unity settings actually have it set to this gray color. But in this half-lambert, you don't get the darkest color happening on the unlit side completely. It continues to keep fading to the point where in the n.l function, -1 would be on the opposite, would be 180 degrees away from the most intensely lit portion on the lit side. So it would be exactly 180 degrees away from 0. And that angle is represented by -1, where 90 degrees is represented by 1, and I think this is 270 down here is represented by 1 as well. But as you can see, the darkest color only appears at -1 for half-lambert, and so I'm thinking that 50-50 gray is probably at the vertical poles, and then maybe 75% gray is down here, and so you have probably somewhere around maybe 25% gray is over there. But if you notice, we never quite reach pure white. And I'm also guessing that even though it almost looks like we might be reaching the unlit color, which should normally be pure black, I don't think we're quite reaching it. So basically, half-lambert is just taking the fall off and then stretching it out to an extreme. So it's not physically accurate. It deals with the fall off problems, but it doesn't quite look right. And in some ways, I originally was thinking maybe it was an approximation to not an approximation, but basically a cheap way to try and fake Ornair, but it doesn't actually look like Ornair. It's not a good match because Orinair's backside or unlit side matches Lambertian's unlit side. But this this particular Lambert would again work pretty well in an area with an intense light and not much global illumination. This one would work if you had a 2D scroller. If it was some sort of game where you cannot see the unlit side, so you, because it doesn't look physically accurate back here. You wouldn't have light just creeping around the edges unless it was made out of, unless the object was made out of some sort of special material that would allow light to kind of travel along its rough surface. So that's how those two function. Now this one is wrap diffuse. I don't know if it's based on Lambert or not, but it's basically kind of allowing you to just control the fall off. It actually allows you to control the fall off, but there's no independent controls to control the unlit side's final color. This is not my shader, and this one actually has a pitch black unlit side that's not using Unity's define unlit color. I'm not exactly sure why that is. And there is another odd thing going on here because when I set the roughness to, I guess, 100%, we have a pure flat white shader. If I set it to something that's not full Lambert, well, because when I set it to 0% roughness, it kind of tries to model this. It would be the same if this was the same color as this. So if we go somewhere in the middle, it looks like we can kind of make it look like half Lambert, except for it's brighter. This actually is probably a better looking half Lambert because it actually has the full brightness. It seems to be reaching white on this side. And if I turn it completely around, well, it still has the same problem with light kind of leaking onto the unlit side, but that's what wrapped does, and that's what half Lambert does. So basically, I think wrapped diffuse is a controllable half Lambert, but it's still not a good approximation of Orinair over there. But it looks better on the front side than half Lambert. So you could also probably use this as for a TD scroller. And then the last cylinder is the Orinair model. And so the Orinair model, instead of having a wrapped component, it has a roughness component. So I can decrease and increase the roughness. If I decrease the roughness, it basically looks like the Lambertian lighting model. If I increase the roughness, we're getting something that kind of looks like a little bit like half Lambert, but it still has a much brighter brighter lit side, especially where the actual where the most intense area of lighting is, and it doesn't have the problems that wrap diffuse has, where it just suddenly completely blows out and turns into flat shading. And it also doesn't have the problems that these two have with the backside or the unlit side having light leaking around. So it's not a wrap. It doesn't behave like a light wrap. which is how half-lambert behaves too. But it looks like, I would say that ordinary, the way it behaves on the lit side is somewhat similar to some of the settings for, it's similar to how you could set the wrap lighting, because the wrap lighting kind of seems like it can be set to something that looks kind of like a cross between these two, which is how ordinary looks, but as you can see, it's still brighter. In the shader that we're writing, I'm actually going to use a wrap lighting function that is going to be able to approximate, well, not approximate, but it's going to be able to fake the ordinary lighting, because the wrap lighting function that I have in my shader it will not blow out to complete white, or it should not be able to blow out to complete white, and I will be able to get this gray tone in the front, but I'll be able to control the color for the unlit side, so I can make the unlit color the same as this. And I believe, well, not I believe, but I know for sure that I'm not going to have this type of situation happening. So in other words, everything, if it was a sphere, everything past the vertical pole would be one solid color, so there won't be any light wrapping around to the backside. But at the same time, it still will have a softer fall off. So that's what we're going to be doing next. This is just a quick video to show you the different lighting models. There is one more lighting model that I don't have up here. It starts with an M, and it was a lighting model that was created to model the full moon, like ordinary. In a previous video, I said it started with a B. That's not true. It starts with an M, but I still don't remember what it is. So this is the end of this video, and in the next video, I'm going to show you how to create a better wrapped lighting model.